All right.
Thank you.
All right. Thank you, Kristen, for that introduction. I'm going to go ahead and share some slides with you this morning. So, thank you again for joining us here at TIPE, wherever you are in the world. It was great to see the chat kind of running with everybody announcing where they're speaking from or where they're tuning in from. As Kristen said, my name is Stephanie Hendrickson, and I have the distinct privilege and challenge of presenting the state of the 3D printing industry this morning, or wherever it is for you. So just a few words of introduction. I work for a publication called Additive Manufacturing Media, and we cover the applications of 3D printing technology to make end-use goods and services. This is a really interesting job. I get to talk to a lot of the companies that are developing the printers, creating new types of materials, but maybe the most exciting part is getting to talk to the people who are actually using this technology. And the thing that I'm always fascinated to hear is the way that their businesses or their industries are transforming through 3D printing. It's changing the way things are made, it's changing what we make and how we make it and where we make it. So what I'd like to do this morning is take you through 8 areas of transformation, 8 places where 3D printing is making a big difference, and give you a sense of both what I've seen in my reporting and where you can learn more about this throughout TIPE for the next couple of days. So we'll start here. 3D printing is supporting better healthcare outcomes. This is not new. Medical devices are one of the most mature applications for 3D printing that there are. We've seen the hip cups, the spine implants, all these different things. The transformation point that I see happening, though, has to do with point of care 3D printing, bringing these devices, the manufacture of these devices, closer to the clinic and closer to the patient. So we're seeing this happen with dental labs, dentists actually bringing the technology in-house. We're seeing it happen with initiatives to bring things like hearing aids to people all over the world. And then along with that, there's a related trend towards digitization. So those 2 things that I just mentioned, along with things like splints and orthotics and prosthetics, these are all industries that have been very manual, very analog in the past. And now with 3D printing, we're moving towards a more digital, faster, more precise future. And then along with that, we are starting to see some ways that 3D printing is even making healthcare more accessible and more affordable. So these little suture anchors down here are an example of a 3D printed component. They are 3D printed PEC, and they are an alternative to titanium anchors. They are less expensive, which means they're more affordable for the hospital or the clinic. And then the surgeons can feel free to use maybe a few more suture anchors than they would have otherwise. These are things that can contribute to better surgical outcomes. And this is an interesting way that 3D printing is helping to improve healthcare. So you will hear a lot of presentations about medical applications throughout TIPE, particularly in the industry track. We've got a number of great panels planned throughout the next 2 days, but also pay attention to what's going on in the technology track. There's some really interesting presentations coming up about bioprinting and some of the sort of like next applications for 3D printing there. 3D printing is enabling the next wave of space exploration. We've had some really exciting news in the last few years regarding space travel, space missions. So the Artemis mission that launched in December was enabled by a number of 3D printed components that were part of the SLS, the Space Launch System. The Orion capsule that was on board that orbited the moon had 3D printed components. And then going back a couple of years, these are components from the Perseverance rover on Mars. And there are a number of different instruments and systems on that rover that were enabled by 3D printing. So this is a place where 3D printing has really found its stride, its ability to produce these really lightweight, really complex products and parts has made it a really important technology to space, both in terms of scientific research and the commercial space industry that's launching. We're not done yet. There are still lots of companies focused on things like how to bring manufacturing into low Earth orbit, how to apply 3D printing actually in space to produce maybe spare parts or tools or even habitats for astronauts. There was even a presentation this week in the technology track about 3D printing for food for space exploration. So pay attention to that. Look for this across the program, particularly in technology and industry. 3D printing is accelerating electrification. I sort of tailored this slide to the automotive industry, but really electrification is happening all over the place. In dirt bikes, in scooters, in autonomous vehicles, in vertical takeoff and landing aircraft. But I think where it is making the biggest transformation right now is the automotive industry. Companies, whether they are established automakers or startups, they are bringing new types of vehicles to market. They're having to go outside of the typical supply chain. And so we're seeing 3D printing applied to really iterate and improve on the designs of these vehicles. An example over here, these are cartridges for the interior of a car. They were produced as part of a prototype run, but that prototype run included 50,000 parts. That's a couple of design variations in there, and these components went to the test track. They went into various types of sort of pre-sale uses, but some of them actually bridged into production, actually were used in early runs of the car that went into the marketplace. We do have a presentation totally focused on design for the automotive space in the industry track later today. We're also seeing different types of vehicles being made possible through 3D printing, like what Pix Moving is doing. They've developed this sort of skateboard chassis that is made with 3D printed components. They can scale it to whatever type of vehicle they're going to make and then adapt the cabin on top to the particular application. So a greater variety of vehicles is possible. As electrification continues, as additive continues to be adopted, we're going to see this, we're going to see it branch into other types of critical components, things like the copper motor windings, things like cold plates and heat exchangers, and new types of battery electrodes and battery cells. So again, you will see this in industry, but also pay attention to this trend throughout the conference. Number 4, 3D printing is bringing new material possibilities. And I mean this in a couple of different senses. One, it's making it easier for us to use particular classes of materials like ceramics. It's giving us more control over certain materials. So being able to place a carbon fiber, a continuous carbon fiber exactly where you want it. And it's allowing for multi-material builds. So if you have an expensive material, a really high performance material, you don't have to build the entire component out of it. You can apply it exactly where you need to. So for instance, this is a 3D printed magnet. In this case, the entire structure is magnetic, but it doesn't need to be. You could get to a point where you are applying that rare earth element only where you need the magnetism and then build the rest of the structure out of something that's more affordable. And then along with that, we're starting to see new types of materials enter manufacturing by virtue of 3D printing. So things like alloys that have been tailored to specific applications, and then a lot of these newer high performance polymers that have different additives and different high performance properties. So you will hear a lot about new materials over in the technology track, and you'll see some of those applications in the industry track. 3D printing is keeping systems in service longer. So replacement parts is not really a new thing for 3D printing, but I think in the last few years, we've had so many supply chain disruptions that it really is starting to take hold and take off. And it's not always the case that the 3D printed version is going to be cheaper. Oftentimes, it's just going to be faster. So that was the case for this component from Siemens Energy. This is part of a big generator cover. The total part is a complete ring, and it used to be a bronze casting. But the lead time got so long in this component that Siemens Energy decided to do a little bit of redesign. They changed the material. They cut the part basically into pieces that they could 3D print and then reassemble later. And by doing all that, they reduced the lead time from almost a year down to about 18 weeks. So this is a really important application for 3D printing, not just because it's a way of getting companies to see the value, but also because it is making real inroads in solving those supply chain gaps and keeping systems in service for longer. So you will see some of this throughout the conference, but if you're really interested in the supply chain promise of 3D printing, I would go check out the economics track for sure for more on this. Number 6, 3D printing is altering consumer goods. There are a number of things on the market that are 3D printed today, things like shoes, furniture, sporting goods, jewelry. And one of the commonalities across a lot of these products is that they allow for greater levels of customization than we have had previously. So you can get the shoe in exactly the right size to fit your foot. You can get a table that's exactly the shape that you want it and exactly the colors you've chosen. You can get a ring with exactly the design that you want. There's a lot of promise there. I don't think we've exhausted all of the possibilities with consumer goods. But what I find really exciting and really transformative here is the idea that a lot of these things are now being designed with circularity, with sustainability in mind. So this shoe that you see at the top is produced by a company called Hylos. You'll be able to hear from one of the founders early tomorrow morning in the industry track. And this is what the shoe looks like when it has been disassembled for recycling. So you can see that it is only a couple of materials, only a few pieces to pull apart, and it was created with this end purpose in mind. The fact that this could be ground up, these materials could be reused and plugged into different types of value streams later in its life. So I think that's a really exciting promise of 3D printing. You'll hear a lot more about consumer goods in the industry track, but also make sure to check out the economics track where there will be some discussions about sustainability over there. All right, getting a little bit bigger picture here, 3D printing is changing what production means. It's no longer the case that we have to make millions of identical parts in one centralized facility and then ship them all over the world. The parts don't even need to be identical anymore. If you're producing 1,000 pairs of glasses, every one of those frames could be a little bit different. It could be adapted to the person that's going to wear them. We don't have to produce everything all at once anymore. This component is in the center is produced by Replique. It is for their client Sienna Garden. It's part of a lawn chair, and it's a replacement part, but it's one that they produce on demand. So it doesn't have to live in a physical warehouse anymore. It can live in a digital warehouse and then get made only as it's needed. And then finally, production doesn't have to be centralized anymore. We saw a really compelling example of this during the pandemic with multiple users and companies coming together to produce these COVID test swabs. And that was a really great application of distributed manufacturing made possible through 3D printing. I think there are going to be many more applications like that. I think the promise of sort of local production is really exciting. So localized production of products available on a global level. Again, you will hear about some of these things in the industry track, but it's really also a big topic over in the economics track as well. So finally, in addition to changing where and how production happens, 3D printing is changing who can be a manufacturer. It's no longer the case that you need huge amounts of startup capital or a fully tooled factory to bring a product to market. You can get started with just a desktop printer. You can just create parts, create products as they are being ordered. You can put something out into the marketplace before the design is finished to get feedback from your users and incorporate that and continue to iterate even while you're in production. So the upshot of all of this is that 3D printing is becoming more democratized, it's being reshored, and it's bringing more diverse people into this manufacturing field. So you don't have to be an engineer, you don't have to be a manufacturing expert. You can be a dental technician, you can be a parent, you can be a designer, you can just be somebody with a good idea. And that's a big part of what we are celebrating and highlighting at TIPE this week. So this is something you will get to hear from people like this, entrepreneurs and inventors and business owners in the people track, but you will find them all throughout the program here at TIPE. So all that being said, I want to say thank you to Kristen, thank you to Nora and the entire Women in 3D Printing team for organizing this event and for asking me to speak. Here are a few places you can find me on the internet, and I will be hanging out in the industry track for the rest of this event. Thank you so much. I will pass it back over to Kristen.
Stephanie.